So I've worked with grades K through graduate. So I haven't worked formally with kids younger than what would that be, like 5, sometimes a late 4-year-old. And even with the kinder and sometimes as old as like second grade, teachers have expressed concern like, well, how do you get kids to learn how to code or engage in computational thinking or computer science if they don't know how to read yet? So I'm wondering, what would you say to somebody who is concerned about doing any of those things with a pre-reader?
I will say to begin that I'm not an expert in computer science, but I will say that I know a fair bit about young learners and their developmental needs and related to problem solving, critical thinking, literacy, and so forth. And I think that there's an incredible intersection that is where the sweet spot is, which is this idea about executive functioning, critical thinking, problem solving, and literacy and numeracy, which is so much overlap with pre-coding, coding, computational thinking. All of that is about decision making and symbolic logic and thinking that is shared between all of those without any really missteps at all. So let me be a little clearer because I think that's pretty high level. Executive functions are like goal-directed behaviors and attention. So being able to switch your attention, paying attention to things that are important, having some impulse control. Let's face it, the 3 and 4-year-olds and 5-year-olds, a lot of what we do in classrooms is about around those functions. Even if we're doing reading, we're still dealing with and helping to encourage those functions in young children. Critical thinking and problem solving happens from the moment kids arrive at the school and where they put things and how they put them and how they talk to each other and how they interact and how they solve problems is a huge portion of what we do. But if we start thinking about computational thinking and pre-coding, the subsets of that come down to things that are the subset skills of executive functioning, critical thinking in general. There isn't a mismatch. So if we think about just symbolic language, we're talking about pre-readers. They're still learning things like letters make sounds and sounds put together to make words, and words that are written are spoken language that are written. And if you think about symbolic language and pre-coding, we're learning things like an arrow that points one way means a direction, and an arrow that points another way means another direction, and a red button probably means stop, and a green button maybe means go, and so red is stop and green is go. And letters that face one way mean something, and a letter that faces another way, a B and a D, are not the same, and it's all about directionality. All of that meshes together so perfectly. We think about computational thinking and patterns and pattern recognition. Everything in early learning is about a pattern, and not just a simple like red, blue, red, blue, red, blue, or A, B, A, B, A, B, but when I do this, that happens. When I do that, this happens. Those are patterns in behavior, patterns in science, patterns in words. So all of that fits in with what we're doing in pre-coding, which is looking for patterns in syntax and how we make technology do what we want it to do. Of course, the order of things we would call, I guess, algorithms, right? Is also in literacy and in numeracy. The numbers have an order, the size of things have orders. The words have letters in a certain order. The story has order. So it's an order of action. It's also an order of words and language. So if we think about it maybe a little more precisely or more concretely, so a 3 or a 4-year-old are still learning which way is right and which way is left. It's very common to have even 5-year-olds and some 6-year-olds and older still thinking about which way is right and which way is left. When we do coding or pre-coding, we're not only thinking about our own right and left, we're also thinking about an object's right or left. The robot, as an example, right and left. That's seeing something from someone else's perspective or something else's perspective isn't only about directionality, but it's about point of view, which is what we're teaching in literacy, or the way the numbers are, which we're teaching in numeracy. Children that young may not yet grasp one-to-one correspondence. You've seen this even if you don't work with young children, that children can count to 10, but they have no idea what 7 means. They just know to parrot these phrases or these sounds.
Right.
But if we're going to move the bot from here to there, and it has to move we think it's going to take a certain number of steps, which is great math skill, we're going to have to know that one-to-one correspondence. I have to push the button 4 times to go 4 steps. The 4 now means something, literally, not figuratively. So we begin to see how that ties in. And then also, certainly in a direct programmable robot, there is this idea about consequences and actions, and that is a big part of what we're doing in so many other things. So I see this really tight fit. It's not a stretch at all. If we step it up one step a little bit older and we look at something like, say, Scratch Junior, Scratch Junior's blocks are color coded as if they're parts of speech. There are action blocks, those are verbs. There are things like shrink and grow, adjectives, or speed, adjectives. And we have nouns, which are the characters, and we have a setting, which is the screen. It's exactly what we're teaching in how sentences work. So we really can see those connections so clearly. For me, it makes a whole lot of sense. And it's not about adding something, but it's giving a new tool to practice and learn and explore the things that we value already with young children in teaching and learning.
Right. And the tools that you've mentioned use like icons or symbols rather than words when engaging in the programming language, which is great for pre-readers and even kids who are learning English.
Correct. And so while in my first robot classroom experience, we used a written language logo, so you had to type SD to go forward. For some of the children I was working with, those were simply symbols. F and D together meant move forward. It was no different than using an arrow. But it's true that a lot of the best tools, in my opinion, for early learning in technology, the technologies or the tools themselves are language free in that they don't have English symbols on them. They don't have Spanish symbols on them. They are simply symbolic tools. So they have arrows or color codes or whatever. And most of the ones that we use with the very youngest learners don't have any screens at all either. So they're directly programmed by the bot themselves.